How are we, my darlings? Welcome back to class 7 of Unit 1. So, looking back on our roadmap of Unit 1 so far, we started with equations with only one variable on one side. Next, maybe we had some like terms to combine, but still all on the same side. And from there, we amped it up to equations with variables on both sides of the equal sign. Either way, whether it had one solution, no solutions, infinitely many solutions, every equation that we've encountered has had only one type of variable. All x's, all y's, all z's. But our past experiences in math should tell us that this probably won't always be the case. A lot of the time, we're going to have more than one different variable to work with. For example, say I want to find the circumference of a circle. Well, there's a formula for that. In fact, there are two. Do you remember the two formulas? What do you need to know about a circle in order to calculate its circumference? Take 20 seconds, pause. What do you remember? Go ahead. Okay, well, you've got a little visual here helping you out. One thing that you need to know, you could actually have either one, but this green line that goes all the way across my circle and passes through the center can be really powerful. It has a fancy mathematical word. It starts with a D, it ends with an iammeter. It's called the diameter of a circle. Equivalently, I could also know, maybe not all the way across, but halfway across. So if I go from the center out to a point on the circle, this gives me another mathematical word called my radius. So say that I want to use the radius. Well, to calculate its circumference of a circle, if I take 2, I multiply it by this fancy number pi, which we're going to talk a little bit about more. If I multiply that by the radius, that's one way to get my circumference. Equivalently, well, a radius is halfway across, diameter is all the way across, so I can fit 2 radii into one diameter. So interchangeably, pi times the diameter, both of these are equivalent ways to get my circumference. And that's cool and all, but like, why? Too often, we commit our formulas to memory without remembering where they come from. Where does this formula for circumference come from? I'll give you a hint. It comes from the meaning of pi. Like, what is pi actually? Where does pi come from? And using that definition, how can I take it to get the formula for circumference? Okay, well, hopefully you've done some thinking, and now that you've thunk, well, pi, you may remember, pi, well, where does it come from? It comes from the oven. But if I'm talking about like mathematical pi, it's an irrational number, meaning I can't write it as a fraction. However, pi is a ratio. It in fact comes from the ratio of a circle's circumference to its diameter. So if I take the circumference of a circle divided by the diameter, I get this number pi. And briefly, you may remember the reason why. Well, pi is about 3.1415926 something. The idea is that if I take the diameter of a circle is curved, right? I'm trying to measure circumference, which is a fancy word for the distance around a circle. I don't know really how to measure a curved length, but if I take the diameter, which is a straight line that I do know how to measure, if I imagine wrapping the diameter around the circle, then that would be another way to calculate the circumference. So if I measure the circumference in terms of the diameters, it takes approximately 3.14 diameters to go all the way around the circle, meaning if I take the circumference, I can divide it into 3.14 diameters. Cool. But then how does that help me get to the formula for circumference? Well, think about it like any other equation. The formula for circumference has the c by itself. Here, if I think just like any other equation, connect it to what we've done before, how could I change this to make it look the way that I want it to look? I want c by itself. What's in the way? And what choice could I make to make this look the way I want it to look? Go ahead. Take 10 seconds. What could I do to get c by itself? Well, here, all I need to do The thing connected to the c, well, that's the diameter. How is it connected? By this fraction bar. And a fraction bar is just division. Well, if I want to undo division by this variable d, let me use multiplication by this variable d. Multiplication, division, they undo each other, and I'm left with pi times d equals c. Well, would you look at that? That is exactly where I wanted to go. Yay! So that's the idea, right? Sometimes taking an equation that I've worked with and rearranging it can put it into a more valuable form, or at least for the purposes that I'm using it for, a form that I would prefer it to be in. So the title of our lesson today, let's talk a little bit about rearranging some equations. Cool. So with that in mind, here's another formula that you've seen before. You may remember from our experience working with word problems that if I take the rate that I travel and I multiply that by the time that I travel, I'll get the distance that I travel. Okay, well, what if I want to solve for r? Like, what if I know the distance and the time and then I want a way to calculate the rate? So if I'm asking you to solve for r, think back to what it means to solve for a variable. Not necessarily to solve an equation, but to solve for a variable. What am I actually asking you to do? Take 5 seconds. What am I asking you to do here by solving for r? Go. 5, 4, 3, 2, 1. Well, if I'm solving for a variable, remember we've established before, solving the equation means to make the equation true. Solving for a variable, though, means, well, when the equation is solved for the variable is isolated. So what I'm asking you to do here is to get r by itself. And same idea here. Well, what's connected to the r? The t. How's the t connected to the r? Multiplication. How could I undo multiplication by t? Well, let me divide by t. On the right side, times t divided by t, these go away. And on the left side, well, I have distance divided by time. So what that tells me is if I take the distance that I travel and divide it by the amount of time that I travel, that should give me the speed at which I traveled. Cool. So there's your idea, right? But why do this? Why bother? Well, in math, as we've kind of alluded to, certain forms of equations are often more useful to us than others, depending on the context. So frequently, we'll want to use that skill, that superpower mathematically that we've established, of making things look the way we want them to look. Some places where that superpower can come in really handy-dandy, let's say that I'm working with dimensions of shapes. So like for our first equation here, this is the area of a rectangle. Area is equal to, well, if I take length and I multiply it by width, I'll get the amount of space that my rectangle covers. But what if I want to find the length and I know the area and the width? Well, how could I rearrange this equation to get it to a place where length is defined in terms of the area and the width? Alrighty. Well, if I want to get L by itself, all I need to do is get rid of that W. Well, how is the W connected to the L? By multiplication. So not unlike our equation above, if I divide both sides by this W, on the right side, they'll go away, just left with the L. And so that tells me here, if I take area and divide it by width, that's one way to calculate the length of a rectangle. Cool. Try it again with these two formulas below. I've got the perimeter, in this case of a rectangle, 2 times length plus 2 times width. And I've got the volume here of a cylinder, pi r squared times h. So in both cases, I've given you a variable to solve for. Again, your goal is to isolate that variable. What sequence of choices are you going to make, and in what order to get that variable by itself? Give yourself a 2-minute timer, pause the video. Let's do it. And stop, put your hands in the air, shake them like you just don't care. Let's solve for W. P equals 2L plus W. So in this case, I want to get W by itself. Well, reverse order of operations tells me the easiest thing to get rid of. I have a 2L and a 2. Let's get rid of the 2L first. I'll do my addition and subtraction before I do my multiplication and division. On the right side, 2L minus 2L, well, that's 0. Then I've got P minus 2L. That's equal to 2W. All I need to do now is get W by itself. Well, I've got a 2 connected to it by multiplication. Let's undo it with division. So that tells me that P minus 2L all over 2 should be equal to our width. So if I take the perimeter, subtract 2 times the length, and divide that number by 2, that should be equal to the width of my rectangle. Let's try it again here with our volume. Volume is equal to pi r squared h. I want to get h by itself. Well, here, pi and r squared are both connected by multiplication. I could do them one by one, but in this case, I'm actually going to save myself some time by dividing both of them at the same time. So I'll divide both sides by pi and r squared. On the right side, both of them undo each other. And on the left, well, I'm just left with v divided by pi r squared. That should be equal to our h. Cool. So take volume, divide it by pi times radius squared. That should give you the height of your cylinder. Cool. One other place where this could be a powerful skill, sometimes you're working with dimensions. You could also be working with temperature. So our first formula for temperature here, this variable K, maybe some of you have heard of Kelvin. Kelvin is another measure of temperature. You'll see it a lot when you get into like chemistry and physics. Well, Kelvin can be calculated by taking a temperature measure in Celsius here, C, and adding 237.15. So we'll do this one together super quick. If I want to get C by itself, well, what's standing in the way? 5, 4, 3, 2, 1, and stop. I have 237.15. It's connected to the C. I want to get rid of it. How am I going to do it? Well, I can use subtraction. So I'm going to subtract my 237.15 from both sides. Well, K minus 237.15, that's K minus 237.15. On the right side, right, plus and minus undo each other. So I'm just left with my Celsius. So say I've got a temperature in Kelvin. If I subtract 237.15 from it, I'll get the temperature in Celsius. More powerful for me though, like I'm more used to dealing with Fahrenheit. So let's say that I have a temperature in Celsius. Maybe I have a friend who lives in the UK. They tell me it's some degree Celsius there. I want to figure out what approximately we're working with in the US, imperial, whatever. So is it imperial? I don't know. Fahrenheit. Either way, I want to calculate this in Fahrenheit. So again, same idea. I want to get my variable C by itself. What choices could I make and in what order to get this variable isolated? Go ahead, try some stuff out, see what works, take a risk, take a chance, and we'll chat. And we're chatting. So in this case, I've got C, I've got 9/5 joined by multiplication, 32 joined by addition. Reverse order of operations tells me that this 32 is easier to get rid of first. We'll subtract 32 from both sides. So I've got F minus 32 on the left. I've got 9/5 C on the right. All I need to do now is divide both sides by 9/5. A cheat code, by the way, when I'm dividing fractions. Remember that division is the same as multiplication by the reciprocal. So instead of thinking of F minus 32 as being divided by 9/5, I'm going to think instead as multiplying by the reciprocal of 9/5, which is 5/9. So 5/9 times that F minus 32. I'll use my parentheses to make sure that whole thing gets multiplied. That should be equal to C. Fantastic. So if I take my temperature in Fahrenheit, I subtract 32, and I multiply that by 5/9, well, now I can tell my British friend what the temperature is in their silly little Celsius. Cool. So we've been working in terms of formulas up until this point, but we don't necessarily have to. The symbols that we're working with can also be kind of random. So take these three. Again, same goal. I've given you a variable to get by itself. What choices are you going to make, and in what order, to make these equations look the way you want it to look? Isolate your variable, use your inverse operations, what's standing in the way, and how you're going to get there. Give yourself a 3-minute timer, play around, see what you get, and we'll come back. Alrighty, let's do it. So here I want to get q by itself in the first one. Well, easiest thing to get rid of here first, I've got my fraction bar. Let's get rid of my fraction using some multiplication. So instead of dividing here, I'll multiply both sides by s. Well, I have s times t, which is just st, and then I've got p times q times r. Well, I want to get q by itself. Same move as I made above with the volume, right? I have p and r both attached to q by multiplication. Let's undo both of them with division. I'll do it at the same time here to make my life easier, save myself some suffering, because who wants to suffer? I've got q here left over on the right, and then I've got s times t divided by p times r on the left. Fantastic. For m here, I want to get my m by itself. Well, I've got a couple things standing in the way. Reverse order of operations tells me I should probably get rid of this j before the n. So I'll subtract j, I want to undo a positive j, minus j from both sides. I'm left with negative m over n equals k minus j. And then here, I've got division by n to get rid of, but I've also got this negative sign. Again, if you're being strategic, you can make your life easier by doing it all in one move. Multiplying by n will get rid of the n. But what could I multiply by if I also want to get rid of the minus sign? Take 5 seconds, go. What else could I multiply by? 5, 4, 3, 2, 1. Well, instead of multiplying by positive n, let's multiply both sides by negative n. That should get rid of both my negative and my n in one move, so the negatives cancel out. The n's undo each other. I'm just left with my m here, and then if I take that negative n, multiply it by my k minus j, then I should be happy. If you want to, by the way, you're welcome to distribute. I'm not going to, because I'm in the business of making my life easier, and if I distribute, then that makes my life harder. But if you want to distribute, you wouldn't be wrong, right? Negative nk and then the two negatives, so negative nk plus nj, totally fine. I'm going to leave it like this and save myself some suffering. Okay, and then finally, a plus b over c plus d is equal to e. I want to get this a by itself. Well, I have a denominator to get rid of. Don't be fooled by the fact that you see a c plus d here. All I'm doing is undoing division by whatever the denominator is. So if I multiply both sides by the denominator, then I should be able to undo it. So here the denominator is c plus d. I'm going to multiply both sides by c plus d. That leaves me with an a plus b on the left. And on the right, well, I have e times c plus d. I'm going to use my parentheses here, be strategic, and make sure that the entire thing gets multiplied. Last thing standing between me and a by itself is this pesky little b. I'll subtract b from both sides. Usually I don't want to get rid of bees. Bees are helpful pollinators and they help save the environment. But here, they're standing in the way of my goal. So a is equal to e times parentheses c plus d minus b. Again, if you distribute here, are you wrong? Absolutely not. Am I going to distribute here? No. Why? Because I like making my life easy for myself. Cool. So, let me give you 3 more to percolate on, and then we're done. So same ideas as above. Here, I've got my formula for the volume by the way of a prism. I've got some random thing in terms of x's and u's and v's and w's and z's. And then finally, this area formula, maybe you remember, is for a trapezoid. So let's say I want to solve for my indicated variable here. Again, get that variable by itself. What's in the way? What choices can I make and in what order to make this look the way I want it to look? Ándale! And stop. Okay. V equals L times W times H. I want to get H by itself. Well, what's connected to the H, the L and the W? How are they both connected? Multiplication. So I'll divide both sides by L and W. Again, I can do it in 2 different moves, but I want to make my life easier. Let's do them together. So if I take my volume, divide it by my length times my width, that should give me the height, in this case, of my prism. Cool. Solving for you, much like above here, don't be thrown off by the W minus Z. I just want to get rid of division by the denominator. So let's multiply both sides by the denominator to undo it. W minus Z, both multiplication and division, these undo each other. I'm left with that v plus v plus u on top. And then I've got x times w minus z. I'm going to use my parentheses here to make sure that all of it gets multiplied. Last thing between me and u by itself, well, there's a screen. But in this case, the variable u is connected to this v by addition. I'll use minus v to undo it. So then I've got x times parentheses w minus z minus v equals u. Again, is it wrong to distribute that x? Absolutely not. Am I going to? Absolutely not. And finally, area is equal to height times base 1 plus base 2 over 2. By the way, don't be thrown off by these little 1s and 2s. They're just subscripts. So they differentiate in this case between the first and second base of the trapezoid. They're not exponents. They're not like times 1 or times 2. Just a way to distinguish. So b little 1 is a variable. You'll hear me say b sub 1. And b little 2 or b sub 2, it's just a separate variable. So I want to get the first base here by itself. Easiest thing to get rid of first is that division by 2. So I'm going to multiply both sides by 2. On the right side, those 2's undo each other. And I'm left with 2 times a is equal to h times parentheses b sub 1 plus b sub 2. Now I need to get rid of this h, right? I can't get rid of the b2 because it's in a parentheses. Reverse order of operations tells me I have to leave my grouping symbols till the end. So now I'll use division by h. I've got 2a over h is going to be equal to that b1 plus that b sub 2. Last thing between me and the b sub 1 by itself, I'll subtract the b sub 2 from both sides. On the right side, they undo each other. And on the left, I've got 2a over h minus b sub 2 will give me the length of my first base. Cool. So we will do some more practice with this tomorrow, right? It can seem a little bit scary and a little bit foreign because we've got a lot of different symbols instead of just the numbers that we like. But don't be afraid. We're going to get plenty of practice, and I promise that we'll feel better. And if you don't feel better, that's not my problem. I'm kidding. Of course it is. It's my job. Anyway, take care. Be good. I will see you when I see you. Have a lovely rest of your day. Gute Nacht. Or Guten Tag. I don't know. Maybe it's really early when you're watching this and it's technically Tag. Or maybe it's the middle of the day. Whatever. Goodbye.